Imagine you can just tap into a liquid order book for both perps and spot and just build smart contracts that interact, not just through an EOA, but through something that's like programmed into a contract.
Hey everyone, thanks so much for tuning in today. Today I am joined by Luke, who's the solutions lead at LayerZero, as well as Xulian, who's the head of ecosystem at Hyperliquid. Today we'll be chatting about some really exciting developments on both sides, as well as walking through some of the technical architecture of both the solutions that we've developed to build on Hyperliquid. Would love to get started by just what is your definition of Hyperliquid, right? I think a few months ago we saw the Hyper EVM launched, and now we have this very interesting juxtaposition between Hypercore and Hyper EVM. Can you explain just the grand view of things and really the differences between those two?
Yeah, it's a great question. I think kind of to put simply, it's the base layer blockchain that kind of will house all of finance in the future. So Hypercore enables high frequency trading, staking, a lot of things that can happen kind of natively. And then the EVM enables like full programmability. So anyone can come in, build new custom apps, and then interact with Hypercore in new unique ways.
Gotcha. And would love to talk a little bit more about the origin story behind Hyperliquid, right? So, what really inspired the vision for Hyperliquid in the first place? Was it simply that just, traditional AMMs and Oracle-based perp dexes weren't providing a good enough UX? Really, what was it?
Yeah, I mean, it was really born out of like a clear need for transparent venue where people could trust what they were trading and that funds were all there, that there was transparency in the trades that were happening, that what was actually happening was truly happening and not something else was, with experience of other exchanges that have gone down. Users thought they had their funds and they didn't. So self-custody, transparency, and just trust in a system that works well.
Gotcha. Yep. And I think today Hyperliquid has found like a ton of product market fit and success amongst the crypto audience, right? Like a lot of crypto assets are listed on Hyperliquid perps like very quickly after launch, right? And we've seen like a ton of volume and just increasing OI over time. What do you think has led to that? And eventually, how do you see expansion beyond like a crypto native audience? And maybe this will allude to like HIP3s, which we'll get into later, but would love your take there as well too.
Yeah, I mean, it's kind of expanding on what has like how crypto has evolved over time. Like perps are just some of the best way that you can actually get exposure to markets in a simple manner. A lot of people can understand them really quickly. They're pretty straightforward in terms of like directional bias and how people want to get exposure. It was not new. Like perps have been around for a while. Hyperliquid offered a very simple, accessible way for many users to, have self-custody, have transparency, and then trade, and then see that they're, trading against other real people. We've actually had a lot of non-crypto people like on board, which is really cool. I think that'll just continue as kind of the flywheel expands and there's, more apps, more front ends. We'll probably touch on that later, but it's something that I'm sure will continue.
Awesome. So when you visit hyperfoundation.org, the kind of big letters pop up, right? The blockchain to house all finance. In your opinion, what is Hyperliquid kind of doing to accomplish that vision? And how do both Hypercore and Hyper EVM kind of fit into that?
Yeah, good to kind of expand on that. It's kind of housing all finance is a future where kind of all financial activities end up happening on Hyperliquid. So that can be trading, that can be structured products, options, real world assets, everything that revolves around finance, borrow, lending can happen fully on Hyperliquid. So Hypercore enables trading. So that's a very big component. Order books have, been around for a long time. It's the best way to exchange with other people. And if you have a transparent on-chain order book, you can have that guarantee that you're trading with a party that has the funds on the other side and so on. And then EVM just enables like full programmability. So you can build complete apps, lending markets, options, a lot more elaborate types of products fully on chain, and then tap into that deep liquidity that's live already. So we'll go into a lot of more on how you can actually create really cool applications tapping into that liquidity, but it's kind of that vision of everything can be in one place.
Gotcha. Yeah, I think that vision has really caught fire with like just the general crypto crowd, right? Like there is a growing number of people who sign all their tweets with Hyperliquid now. So I think that speaks volumes about like how much a community role plays in kind of like all of Hyperliquid's developments, right?
Yeah, I mean, community has been awesome. It's really cool to see how they've self-organized and just really taken charge on a lot of initiatives. So it's really about fostering that like healthy community kind of trying to give examples of other like people in the community, but it's been just like really cool. Like they'll go on podcasts and talk about Hyperliquid, even though they're building a completely different
Right.
project. Yeah, the signing of Hyperliquid was born also like out of the community, which was really cool. Like it's never been forced.
Yeah, yeah. And I think with Hyper EVM now, there's this completely new aspect of the community where previously it was mostly user-based, right? And now you have a bunch of builders who are coming together to put this really cool DeFi ecosystem that's very cohesive and has linking back to Hypercore together, right? So can you speak about how inspiring it's been to like kind of feed upon this new wave of builders who are actively working to make the EVM better?
Yeah, I mean, the EVM was kind of born because of the demand. It's really cool that a lot of the users are actually builders as well, and they wanted to build on top of Hyperliquid. They kept asking, like, how can we do a bunch of different things? As like the EVM has come out and is continuing to roll out, it's been really cool to just see how people kind of come together. This is missing, someone goes out and builds it. Yeah, I can call out a bunch of different community members that have just been contributing.
Yeah, awesome.
From a cohesive group of the shared ledger between Hyperliquid, Hypercore, Hyper EVM, how did you think about the combination of those two from core principles? And then we think about the shared ledger of the actual blocks being on this shared ledger through core blocks, EVM small blocks, EVM big blocks. And like, what was the thought process behind that versus, hey, we have this application that's running on its own VM, rather than expanding that to multiple VMs, we're doing this in a unique way and like making it one unified place?
Yeah, I mean, there's kind of a lot to expand on that, but really it was about how can you have this, like, this, I think Jeff used the analogy of a jet engine, essentially. You have this in-flight engine that is already operating, handling 1,000 transactions per second, and then you want to add programmability. If you just add that in to the same environment, things can break, and you really don't want to mess with that. So it was about adding an environment where you could have full programmability and then still have that same security and consensus that HyperBFT offers. So it's about, offering those two things into the single kind of package that is the L1.
And what do you think like that will ultimately unlock for composability, right? And we at LayerZero, we view this, the Hyper-V EVM actually as like an incredibly powerful layer for composability to invoke different actions to interact directly with the exchange, right? So when going through like small blocks versus big blocks, how did you guys think about that? Like, can you share like examples of like the two?
Yeah, I mean, the small blocks versus big blocks was about, you have an average user that performs certain actions. They don't really need that much gas availability. They just want to perform a swap. They want to perform a send. They want to do a lot of basic actions. And then you have builders that are deploying pretty big contracts. They don't really need high throughput. They don't need, extremely fast blocks. They just want to make sure that every so often they can deploy larger contracts. So big blocks, small blocks was kind of born of that in managing, state growth as well. So you have the fast blocks for most users, and then builders come in and can leverage the big blocks to deploy bigger contracts.
One thing that's really fascinating about the kind of Hyperliquid product stack is that it's ever expanding, right? I think right now there's like this massive user base, but there's only going to be more users as like Hyperliquid continues to grow and iterate on what's already there. And so I think some really cool, exciting initiatives that you guys have coming up are builder codes and HIP3, right? Would love to just hear more about both of those. So we can probably start with builder codes first.
Cool, yeah. Builder codes are like already out and they're really cool. I think there's been a lot of cool applications that have already been built and a lot more kind of in the works. But essentially what they allow, they unlock monetization for builders kind of straight away for anything that's routed through their front ends, through their applications. Any trade that happens there, they can instantly monetize and then have that like healthy flow of funds day one without worrying about a complicated backend. They worry more about the user experience, user flow, new UIs and things like that. So we've seen cool different apps. PvP Trade was one of the first ones to leverage builder codes really well. They've created a Telegram trading app. They really leaned into the social aspect. It was a completely different experience to what you have on like the main Hyperliquid front end. So that was like an example of something that was unique, different, and users enjoyed interacting with. There's been a bunch of other apps since then. Dexari is building a fully mobile app, Octo Wallet, and then I can kind of go down the list of all the other ones that are building unique experiences there. But I'm sure we'll see a lot more of people tapping into builder codes just to leverage. You have really deep liquidity day one. You don't have to worry about, you know, building that liquidity, which tends to be the hardest part of an exchange. You just build it on a cool interaction and something unique for users.
And I think that it creates this really interesting flywheel too, where like you have builders who are almost serving as distribution hubs for like Hyperliquid tech, right? So can you talk more about the flywheel effect there between like builder codes and ultimately what those builders are pushing out?
Yeah, I mean, the flywheel is pretty straightforward. Builders bring in more flow brings in more liquidity brings in more flow, and it just kind of keeps feeding itself. Most of the time, order books have this kind of chicken and egg situation of you don't have good flow, so you don't have good liquidity, but liquidity won't grow until you have good flow. And then, you know, with different experiences and different distribution models, you can actually, you know, essentially add gas to that flywheel and just kind of let it continue to leverage. So, you know, more ways to interact with a single liquidity hub just adds to that. You know, you can have builders in regional markets create a regional exchange dedicated for a very specific audience. You can have like totally unique ways to interact. We've seen, you know, whether it's AI agents or, you know, Telegram trading bots, as mentioned, full mobile apps, news trading, like you can really expand a lot more with that.
Gotcha. Yeah, one thing I thought was interesting about builder codes is that 10 bips is like hard coded in as the max fee that a builder can take. Do you see that as being static in perpetuity or kind of being dynamic over time?
Right now, 10 bips is the max. It's a lot. Like, so most of the time they don't need to do more, but it's also like up to builders. So if there's like strong feedback on a reason why they want that, like there's always like a response to that.
Gotcha. Okay. And then the next initiative, I think there's a lot of fascination around it for sure. And maybe this goes back to my earlier question about how we expect to onboard maybe people who aren't crypto native, but just more general retail or anyone looking to trade in general, and that's HIP-3s. So can you explain a little bit about what those are? We've seen like a bunch of big names in this space kind of building and experimenting on testnet. So would love to kind of just dive into what exactly those are.
Yeah, HIP-3 or, you know, Hyperliquid improvement proposals are just, the HIP-3 specifically refers to permissionless perp deployments. So it's relatively straightforward. A deployer can deploy any type of market as long as they provide an oracle. And then with that oracle, you have a perps market on the, you know, trusted and high performant Hyperliquid infrastructure.
Gotcha. And what are the markets that you think we're seeing there? I know there has been like things like traditional equities, commodities probably comes into play, maybe things like FX in the future. How do you see the list of HIP-3 markets kind of growing over time?
So deployers are free to deploy whatever they want. I'm sure there will be markets that traditionally aren't 24/7 turn 24/7 because you can have that access in crypto. So we'll see a lot more. Kind of the sky's the limit on what users and builders can deploy there. So as long as they can provide a reliable oracle and good infrastructure, and you know they build their front end for that, I'm sure they will see very interesting things.
For sure. Yeah, super interested to see kind of the selection in markets branch out of just crypto assets.
Yeah, so something that we as LayerZero came across when we were first building on Hyper EVM when it came out was this concept of like read and writes. So like read precompiles and write system contracts. I guess from your perspective, like how have you seen those evolve since kind of earlier this year when Hyper EVM went live, and then just the folks that have been testing it out on both ends, on the read side and the write side, and like how do you see those working together in the future as the EVM grows?
Yeah, I mean, precompiles are for reading. So smart contracts on the EVM can just read information that's happening on Hypercore directly without having to go off chain. That enables things for like lending markets to have a reliable oracle for, you know, spot Bitcoin or spot ETH or spot Hype or all the other spot assets. So you can tap into that oracle directly that's posted to the chain, or just read different balances. I think a lot of the extra reading that is available will really be unlocked with Core Write. So Core Writer is where you actually can perform actions, which that's where it gets really interesting. So you can essentially have a smart contract that interacts directly with Hypercore, and that can be for trading, it can be for staking, for depositing into vaults, to sending to users, performing kind of anything that an EOA can traditionally do. So once you kind of combine that, it just unlocks a whole world of possibilities that were previously not available.
Have you seen anyone, I guess, in testnet or testnet today, kind of trialing anything out between that composability of using, like, say, collateral from positions on Hypercore and using it in EVM? Have you seen kind of some sort of like first mover examples or use cases that are using that read and write to their advantage for their application?
I mean, there's definitely been teams kind of exploring what can be done. I know there's a team that was exploring if you can tokenize a perp position and then borrow against that. There's a team that wants to tokenize HLP and then borrow against that with like its continuous yield so far. So there's kind of a lot of different things that you can expand on there. I think there's going to be a lot more interesting things. Money markets, I believe, can benefit a lot more, but there's also like a variety of applications that we just haven't seen yet because people are just not ready to build.
So Hyperliquid primarily on the perp side was or has been just USDC pair against any tokens, and kind of going off the back of HIP3s with the sense of like permissionless deployments. How does the Hyperliquid team or just in general see how that like pair asset across order book may work in the future? We've seen folks like USDT0 really lean in and expanding to Hyper EVM as well as Hypercore, as well as kind of Athena and USDE. How do you see the order book expanding in the future for like creating new markets with different pairs?
Yeah, so from the Hyperliquid Lab side, there's been efforts to build, multiple collateral options. So you can have different base pairs, and then that enables new teams to come on and build. So, if you're deploying a stable coin, at some point you can also deploy your different base asset essentially to be paired against different, be the base for all these other pairs, and then also at some point become a perp.
I think we've talked about a lot of really interesting concepts and developments, but I think to give like a visual representation of everything that we've been talking about, it'd be best if we could whiteboard some of this stuff out. So we'll have Luke and Julian kind of go to the whiteboard and draw out some of the items that we talked about.
So in general, LayerZero is just like blockchain interoperability protocol. So it's really any app on any chain that LayerZero supports can send any data. That can be tokens, that can just be general instructions. It can be composed multi-transactions, anything that they want to do has full composability across any chain. And so how that works is really just LayerZero endpoint smart contracts. They're mutable sets of smart contracts on every chain, one per chain, and apps can just configure to that interface on a send and receive side. So they can send and receive any information that they want. So we have certain contract interfaces that you can have a contract interface for just general messaging. So if I want to just send instructions, no data or no value itself, I can do that. And then we have an interface for fungible tokens specifically, which is one of the most widely adopted token standards in the industry, which is the OFT standard. And so what the OFT standard does in a very simplistic way to move tokens is it burns an amount of tokens on the source chain, sends that message to the destination chain to mint equivalent amount of tokens to the user's account balance. And so this is kind of a very new way to manage value transfer across any environment without any liquidity pools, so super capital efficient, can transfer any amount for the price of gas, and it's an easy way for native assets to expand in new chains and connect and unify that supply. We had this idea of really just for exchanges in general, there's typically an overhead that comes with the user experience, as well as the exchange itself having to manage inventory supply on each chain for the specific assets. So it's asset to chain pairs, and so that users can only deposit and withdraw certain assets on certain chains, and that is beholden to what the exchange supports. And so having a system that's all on chain was really important for us to like, and I think the aha moment was like, hey, wouldn't it be cool just for any OFT or any person who holds an OFT to just do direct deposits right to the exchange to Hyperliquid and immediately start trading in their spot balance. And so as we kind of dug into this a little bit more, we found out that this is all possible in one click. So as a user, I can pay once and sign once on any chain and directly deposit tokens to my account balance in Hyperliquid and immediately start trading those tokens. And so kind of keeping that unified one-click experience, all of this was really just unlocked from the OFT standard and the core writer component of Hyperliquid, which we'll get to in a second. So breaking down the previous slide in a little bit more detail, so that the super simplified one-click user experience direct to the exchange, how does that actually work under the hood? And so from here, kind of walking through the actual contract topology of the direct deposits and how that works for the user. So I'll do that now. And this is really across any of the 130 chains that LayerZero supports. So if you have an OFT, a token that's an OFT, like USDT0, like Athena USDE, you can transfer those tokens immediately to either Hyper EVM or the exchange on Hypercore through this solution. So how this works today is a user basically has, so if I have any amount of money, say it's USDT0. So I have that in my user wallet balance, pick any chain, and say I want to transfer it. So in one click, so I'll basically send that in a user interface to either Hyper EVM or Hypercore. And what will happen under the hood is that through that invocation, so this will burn the tokens from my balance. A LayerZero message will get sent to Hyper EVM as the hub chain. And so these tokens will then get minted either to my balance if I'm on Hyper EVM, but if I want these tokens to go to my spot balance in Hypercore, these tokens will get minted to a composer contract that the OFT owner, so USDT0 or Athena, they'll own this contract and effectively be able to mint the tokens to the composer, and then from there, the composer contract will use the core rights, so the right to the right system contract for Hyper EVM, which is mirrored across Hyper EVM and Hypercore. So there's a linking between an ERC20 balance on the EVM side and an HIP1, which is the spot, Julian, correct me if I'm wrong, but it's the spot like native asset token type for Hypercore. That's correct.
Yeah, spot assets.
And so once that linking is done, this composer contract will make a call to the destination side. So this is a write. So it's a write. It's not precompile, but what?
Core writer.
Core writer. Core writer. So make a core writer call to effectively say, hey, we want to unlock the tokens from the system contract that's linked, and we want to send the tokens to the user spot balance. So now the user, in one click up front, all of this flow is handled on their behalf. So burn the tokens on the source chain, mint tokens to the composer. These actually get locked in the system contract, and then they get unlocked from the system contract on Hypercore. And so this is a composed flow. And then I think it's important to note that the gas, so because it's one click from the source chain, the entire fee, so gas on Hyper EVM for the transfer, and then the composed flow, all of that is packaged upfront in source chain gas for the user. So they pay for the entire thing upfront, sign once, pay once, gas is handled for them, and they get tokens in their spot balance on Hypercore. So as we have been working with Hyper EVM and Xulian and the team, we've kind of come across a lot of what you can and can't do, or mostly what you can do with Hyper EVM and the certain components that allow you to do that. And so right now, kind of figuring out what you can do with the EVM, how that interacts with Hypercore, kind of really opens the doors of what you can do in terms of composability, like we talked about earlier. And so just to kick us off here for LayerZero, and when we talk about the core writer, the precompiles, and how the EVM interacts with Hypercore, and kind of the order book, vault, staking, all of the applications that live on Hypercore, how does that actually work, right? And so for our example, for LayerZero, we're using the core writer. And so what we're doing here with the OFTs from what we went over earlier is really having this composer contract, right? So the composer contract, and you have the OFT standard. So you'll have the OFT contracts that are kind of deploying the tokens on Hyper EVM. And you have a composer contract that is invoking the core writer to go and transfer tokens to the user's spot balance. But that's just one use case, right? And so I think what this opens up is a variety of different use cases for a really wide range of applications, building either on the EVM or just kind of how do we use Hypercore to our advantage in a different application that we're building that may be a little bit more trading heavy than DeFi applications that live in Hyper EVM. So Julian, I'll let you take it away with some interesting applications that have been building with either the core writer in the read precompiles.
Cool. There's like a lot we can expand on here with HyperEVM, Hypercore, and the interaction. So kind of to preface, imagine you can just tap into a liquid order book for both perps and spot and just build smart contracts that interact, not just through an EOA, but through something that's like programmed into a contract. So lending market's a cool example of something that can really benefit from this. So a basic example would be you have the lending market on this side. So we'll just go with L. Wants to interact with the spot books because it's a deeper, more liquid book to liquidate into. So they would create a core writer action that would then send a sell order, for example, if they're going to be liquidating into the spot order book. So they would send funds from their app through a core writer. They can read that the funds are there, and then they can send the liquidation directly to the spot order book and then send those funds back within that contract's actions. That's like very kind of low hanging fruit of like just tapping into liquidations, but then lending markets can expand a lot more into, for example, hedging the assets that they control. So we've seen in the past there was, lending market that let someone borrow a lot of funds against a semi-illiquid asset. There was a potential of that lending market incurring bad debt. So in this case, a lending market, instead of just liquidating, they would hedge their position. So they can have a smart contract that hedges an illiquid asset over here, uses the perps component, and then has a short. So they're essentially delta neutral, and they don't actually get exposure to the volatility if they're lending out, to a traditionally less liquid asset, or maybe it's not illiquid now, but in the future it becomes liquid. They can always have the hedge so that they will never incur bad debt and can be delta neutral on those positions. And also that enables higher loan to value ratios so that lending markets can actually tap into and enable users to have deeper liquidity. If we use both of these basic actions, then we can get a lot more complicated into what can be built. So another fun thing is self-repaying loans. So you can create a self-repaying loan by tapping both into perps and spot. If someone lends out, we're going to go to the example of Bitcoin, for example. So you got the lending market, they're lending out BTC over here. The core writer can create a position where that Bitcoin is moved over to the spot and perp side, and then you have essentially a delta neutral position that can earn yield. If we go like with the very base funding rate of 10%, say you're paying 5% to borrow USDT 0 on the lending market, but the delta neutral position is actually paying out 5%. That could be self-repaying, or the lending market's just earning extra yield on that. So that's like some different examples of how lending market can kind of continue to scale what they're actually offering to the user. We can go another way of like options protocols. So we'll just do an O for options. They want to offer deeper liquidity day one. So they would just create a contract that allows settlement to happen on spot or perps so that they can always have that deep liquidity tapping into a perp market that's liquid all the time and not have to kind of deal with creating new vaults with new liquidity. And then you're not actually kind of worried about how are you going to leverage that liquidity. You just tap directly into those order books. More fun things that you can do is tokenization. So you create tokens on, for example, vaults. So there's a variety of vaults. There's user vaults. There's the Hyperliquidity provider vault. So HLP over here is pretty popular for some people. So a protocol could come in, tokenize that, and then bring it back. So the read precompile would allow the contract to know, for example, how much the liquidity is in HLP, how much it has deposited, and the core writer can deposit more or withdraw and send back to the protocol that is tokenizing, and then can handle redemptions through that smart contract on one side. Can keep going on like all these different things that can be expanded on, but these are just some examples. Staking is the last one. So LSTs or LRTs, depending on how we want to go with it. So let's go with LST. Oh boy. So LSTs, liquid stake tokens, you can create a contract on Hyper EVM that essentially sends the funds to the spot balance, then sends from spot to staking, and then have liquid stake token that has been staked through a smart contract, and then create that tokenized representation on the EVM all through a smart contract, tapping into Hypercore and those components. Yeah, so these are a couple different actions that we can go through on like what read precompiles and the core writer functions enable within Hyper EVM and Hypercore. With OFT, it also allows, all these other assets to move to and from spot. In the future, if there are different markets with perps, with HIP3, and they have different quote assets, those OFTs can also be sent directly there to the different HIP3 markets. So all that can just happen seamlessly. And on the front end, a user would really only see that they deposited and it went to the correct place where they wanted to have it.
Awesome. Yeah. As we go through all the examples, I think there's more and more of this middle part becoming like this mesh, or this spider web of different types of routing for different actions. And I think it just speaks to kind of how the system was built with these read and writers between the EVM and kind of the wide range of applications that can be built, and like leveraging deep liquidity in various ways on Hypercore. So really interesting to see the ecosystem of applications just build out, and how this composability can like continue to grow, and what interesting apps get built in the future. So cool. Yeah, Julian, really appreciate your time today. Yeah, and looking forward to it. Looking forward to seeing Hyperliquid grow.
Cool. I really appreciate it.
Awesome.